Okay, so here is a video on some exponential growth problems, but they're a little different than what we've been talking about because these are considered percent problems. A lot of the work we've been doing is going to be the same, but instead of having a keyword like double or triple, since this is growth, they're going to have a percent. They're going to grow at a specific rate. And we're going to talk through how to set those up and work through them. So, for our percent problems here, the difference from what we've been doing and what we're going to do today is that these don't triple or double. They don't have a keyword like that in the problem. Okay, like I said before, they're going to grow at a percent, and that's called a rate. Okay, so you're going to see that word in the problems. And that's your key that it's going to be these percent problems. Now, something to remember is that when we're doing exponential growth, our b value needs to be greater than 1. Okay, so a lot of times it's not going to be the percent itself. It's going to be added in there with that rate. And we're going to work through how to do that. And the key skill in doing that is understanding that percents are decimals. Those two things are interchangeable. They're just different forms of the same thing. Okay, well, percents are always out of 100. Now, we can go over 100%. But really, percent's the maximum you can have of something is 100% of it. Okay, so to change a percent to a decimal, what we do is we take our percent and we divide it by 100. That's going to give us it as a decimal. It's really simple. Lots of you are going to be able to do it in your head, but I put the first two examples on here for a reason, because lots of people get these confused. So actually doing the work here where we divide it is going to help you always get that right. So if we have 5 and we're going to divide that by 100, we put that in our calculator and we really get 0.05. Okay, that's key because what a lot of people do is they make the mistake and they treat it as 50%, which is our next example here. If we do 50 divided by 100, we get 0.5. Now these two are not the same thing. Okay, this one is 5%, this one is 50%. So really think about that. If you see something, in particular this one, okay, where that 0 goes. If the 0 is after the number, when we do it as a decimal, it's not going to have a 0 between the number and the decimal. When it's just a number with no 0 on it, we have to put a 0 in there between the decimal and the number that we're talking about. Now, if it's anything else, it's really not that difficult. You just, like I said, divide by 100. And so if we had 37%, we would do 37 divided by 100. We get 0.37. Okay, this skill is key today in order to do these problems. So I'm going to tie this back to the idea of growth. Since these are growth problems, what's happening is they're keeping 100% of what they already had and then adding this new rate to it. Okay, so 100%, if I was going to change that to a decimal, it'd be 100 divided by 100, which is 1. Okay, and remember, our b value has to be greater than 1. So what we do, okay, is we take 1, because they're keeping 100%, and we add our rate as a decimal to it. Okay, that makes it bigger than 1. Okay, remember, for growth, b has to be greater than 1. So what we're doing here is creating a b value that is bigger than 1 for our problems. So again, it's 100% plus whatever our rate is as a decimal. We've got an example here. So it says the money in a bank account grows at a rate of 6% each year. Grows is telling us it's growth. 6% is our rate. It says that right there. So the first thing I'm going to do, change that 6% to a decimal. 6 divided by 100, 0.06. Now I'm going to, since it's growing, it's keeping all of the money that was already there and putting 6% more with it. I'm going to do 1 plus 0.06, which is 1.06. And that would be our b value for this problem. Okay? We're going to use that. That's the key today in order to figure these out, because we have to use that in order to write our problems. So here's our first example. You put $500 in a bank account that has an interest rate of 4%. We have two parts here. First, we're going to write an equation to model the situation. Second, I want to know how much money you would have after 6 years. You didn't do anything to the money but put it in the bank. Okay? So first part, we're going to write an equation. We're going to read through it multiple times. Remember, we want to identify our A and our B. Okay, A is our start. And B, we know is going to have a percent. It's going to be 1 plus that percent as a decimal. Okay, so if I read through it again, you put $500, that's our A value, in a bank account that has an interest rate of 4%. Now, interest implies that it's growth. Okay, keep that in mind because we haven't really talked about that. Okay, interest implies that it's growth. That growth rate is 4%, so I'm going to do 4 divided by 100, which is 0.04. Add 1 to that, so I get 1.04. That's our B value we're going to use for our problem. So our model here, y equals 500 times 1.04 to the x power. Okay, our A, our start, our B is our rate plus 1 to make it bigger than 1 because it's growth. Question 2. How much money do you have after 6 years? Well, remember, that time goes in there for x. Okay, so we're going to do 500 times 1.04 to the 6th power. And you should use a calculator for this. You can use a calculator on your phone if you need to, or any other calculator is going to be able to do it. Just find the exponent key. So I'm going to start with 500. I would put it in the calculator. 500 times 1.04. Either use that caret key or find the x to the y key. That's how you're going to get your exponent. 1.04 to the 6th power. Since we're talking about money here, remember that's 2 decimal places. That's how money goes out. Dollars and then cents. Okay, cents would be 2 decimal places. So our answer is $632. We need to round it appropriately. It's really 659. Okay, so that 9 is going to change this number to a 6, so 66. And there's our answer. You would have $632.66. Let's look at another one. Okay, so example 2. The population of a small town is currently 1,200 people. It is expected to grow at a rate of 12% each year. First thing, we're going to write an equation to model the situation. Now, I underlined grow, because that tells us that it's a growth problem. Okay, next thing we're going to do is read through and find our A and our B. So the population of the small town is currently 1,200. That's our A value, our start. It's expected to grow at a rate of 12% each year. So I'm going to do that. 12 over 100, 0.12. And I'm going to add 1 to it. So our B value is 1.12. We're writing an equation to model. So y equals 1,200 times 1.12 to the x. Perfect. Okay. Second part, follow-up question. What would you expect the population to be after 10 years? Remember, that is our time. It matches, okay, the beginning part and the end, the question, have the same unit of time, which is great. You don't have to convert anything. So 10 is going to go in for x, and it says to round to the nearest whole person. Okay, so we're going to do 1,200 times 1.12 to the 10th power. Again, you want to use a calculator. So 1,200 times 1.12 to the 10th. And I end up getting 3727.01785. Now we're going to round to the whole person. We look here, 0, less than 5, so 3727 with a label, people. That would be the expected population of that town. Okay? So to recap here, what I want you to do is make sure you pay attention when switching to decimals. Remember, we talked about the difference between 5% and 50%, 0.05 and 0.5. Okay, keep that in mind. That's really important because if you use the wrong one of those, the answer is going to be way off. Since we're growing here, our B value should be greater than 1, so we add 1 to that decimal. Okay, I'm going to write this slightly different. I'm going to write it like this. 1 plus the percent divided by 100. Okay, that's going to make a B value greater than 1. Last thing, write your model first. Remember, that's 2 read-throughs. and then answer your follow-up question. What we've been doing, that's our third read-through to the problem. So again, our first read-through, decide whether it's growth or decay. Today, all of these are going to be growth. Okay, so it shouldn't be, that first read-through should be fairly easy. Second read-through, you're finding A and B and writing your model. And then the third read-through is answering that follow-up question. So if you have any questions, be sure you put those in the discussion boards or send me an email. Otherwise, you have a short Schoology assignment, basically doing the same things we're doing here. We're going to talk about money, rounding to 2 decimal places, or populations of things, rounding to a whole number. So example 1's using money, example 2 is a population. So keep that in mind when you're writing your answers. Again, send me any questions you have. Otherwise, good luck.